All right, hello once again. This is Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD 1000 Web Development Technologies course, I've been creating a series of video presentations which are based on the Mozilla Developer Network Learn Web Development series. I'm in the JavaScript portion, and we're talking about objects and object-oriented programming. So in this article, as it says here, we will be talking about object-oriented JavaScript for beginners. Now, it says with the basics out of the way, we will now focus on object-oriented JavaScript. So this particular article that we're reading right now will give a basic view of object-oriented programming theory in general, and then talk about how it's used in JavaScript. All right. So it says to start with, let's give you a simplistic, high-level view of object-oriented programming. It says because OOP can quickly get very complicated, giving it a full treatment would probably confuse more than help. The basic idea is we use objects to model real-world things that we want to represent inside of our program, and or provide simple way to access functionality that would be either difficult or impossible to do otherwise. There are literally scores of built-in objects in JavaScript as in other object-based or object-oriented programming languages. Objects, as it says right there, can contain related data and code, which represent information about a thing you're trying to model. Guess what? You already know that. When we did Bob Smith, we put in there things like that Bob Smith's first name, Bob Smith's last name. I manually added the height and the weight, the eye color and the hair color, etc. So objects, as it says, can contain related data and code, which represent information about the thing we're trying to model, and functionality, or in other words, the behaviors or what you want it to be able to do. Object data, and often functions as well, can be stored neatly or encapsulated inside of an object package. You already know that namespace. That was what we used before with person. Hopefully, at least you thought that made it fairly simplistic to structure and access the objects, the person objects methods, all right, which were greeting and etc. And also the person objects properties. All right. So it says here, let's consider a simple program that displays information about the students and teachers at a school. Here we'll look at OOP theory in general, not the context of any specific programming language. All right. It says to start off with, we could return to our person object that we went through earlier, which defined generic data and functionality for a person. There are lots of things you could know about a person, and some of those are listed there. But in this case, we're only interested in their name, their age, their gender, and their interests. All right. And we also want to be able to write a short introduction about them and get them to say hello. That's pretty much what we did previously with the person object. It says here that what we're doing is we're creating an abstraction or a simple model of a complex thing, which represents its most important aspects as we've defined them in a way that's easy to work with for the program's purposes. From our class, so the person class, we create person objects. Now, they call them person one, person two. Typically, we wouldn't do that. You know, if it were the people who were in our class, for example, we might have a James object and a Nicholas object, something like that. Doing this and actually taking this and breaking it into here, all right, even though they called it person one and person two, which again is okay, we are instantiating objects. So instantiation is the act of taking an existing class and creating objects based off of that existing class. So as mentioned here, when an object instance is created from a class, The class's constructor function is run to create it. Again, this is known as instantiation because you're creating an object instance from the class by instantiating the class. It says in this case, we don't want generic people. We want teachers and we want students, which are both more specific types of people. In general, or in object-oriented programming, it says we can create new classes based on other classes. The child classes are known as subclasses. They're also known as child classes. They can be made to inherit the data and code of the parent. So as it says, they can reuse common functionality so you don't have to keep duplicating it again over and over. When functionality differs between classes, you can put the stuff that's different from them. So in other words, all right, if we could make a student class, all students are students, as an example. But not all students have the same name. Not all students have the same age or gender or interests. So as it says, we could come up and create something generic because all teachers and students do have a name, do have a gender, do have an age. All right, so we could basically make a person class with the stuff that all students and all teachers have. Then for the teachers class, only put in things specific to teachers, and for the student class, only put in things that are specific for students. And as they mentioned there, and this is another one of the hallmarks of object-oriented programming, and that is the fancy word for the ability to create multiple object types to implement the same functionality is also known as polymorphism. Now, I'll very quickly give you the example that I use for polymorphism when I start to go over this stuff in class, and that is, imagine that we had a class called Mammal. M-A-M-M-A-L, okay? And based off of that class, we wanted to create a dog class, a cat class, and a bird class. Well, what we could specify in our mammal class, we could specify a method that was called speak. Now, if you tell a dog to speak, and if the dog knows how, it'll say bark or woof or ruff or whatever. But if you tell a cat to speak, if the cat could learn how to do that, it would purr or say meow, and a bird would tweet. So they're all speaking, but they're speaking in their way, so to speak. So polymorphism would say that for the generic class called mammal, I could create a generic method called speak. And if I created 3 objects, a bird object, a dog object, and a cat object, and I told each one of them to speak, they would know how to speak based on the fact that they knew what kind of object they were. So they knew the way they should speak. Here for the greeting, what's kind of unique in there, so let's see, we've got name, first name, last name, gender. Yeah, the interest would probably be different. The bio is going to be different, etc. But the subject could very well, that they're teaching could very well be different. Here, Dave Griffiths teaches math, Melanie Hall teaches physics, as an example. All right. So in the rest of this article, as it says here, we'll start to look at how object-oriented programming theory can be put into practice in JavaScript. Now, JavaScript, like most other object-oriented or object-based programming languages, use what's called constructor functions to define and initialize objects and features. So let's talk about how you do that. So here they're using what they're considering to be a simple example. You may or may not agree with that. So it says add this. So we want to make a new local copy of this. All right, this was the one that we had in there before with nothing in it. So I'm going to copy that. I'm going to go back to here and we'll remove everything that was here, and we'll put in this. All right, same stuff we had before. I'm not going to pretty it up or anything. It's fine. All right. Next, add this to the script element. Let's add it. So we're putting it in here. And underneath that, they want us to put in some code that will do this. So let's break this down and let's look at it ourselves as opposed to what they show in the book. So we're creating a function here called create new person. And it expects that we're going to pass in to that thing a name. All right, based on that, we're creating an object. And really this should be tabbed over again. The name of that object will be name. The greeting will say, hi, I'm, followed by the name. Since this says salva, when we say salva.name, it should come back with salva. And when we say salva.greeting, it should say, hi, I'm salva. Let's see if indeed that works. So I'm going to save this. I'm going to come back here. And I'm going to refresh. Hi, I'm Salva. All right. And that was the name, and that was the greeting. Now, let's do this. Let's just grab that salva.name, and let's put it in right here. And it's salva, exactly what you'd expect. And if we say salva dot greeting, we just hit enter. All right, we get the code. All right, that's all it does. But if we say salva dot greeting and we put in the parens, now we get our message. Hi, I'm Salva. It says this works well enough, but it's a bit long-winded. If we know we want to create an object, why do we need to explicitly create a new empty object and return it? Fortunately, you don't have to do that. So it says replace your previous function with this. So let's replace it, and it's going to look the same. But let's get rid of this and replace it with this. It's a lot slicker and less code. So when we call this, it shouldn't now be create new person. It should be person. All right, we're passing it in Salva. So that Salva becomes this Salva. That name becomes the name that we're putting in here. And the greeting is an anonymous function that should say, hi, I'm Salva. So if we save this, go back into here and refresh. All right, it says cannot read property name of undefined. Okay, so we've got here salva.name, that this dot name equal name. Well, let's see what we were supposed to do because I didn't do something I was supposed to do. It says here the constructor function is JavaScript's version of the class. Notice it has all the features you'd expect in a function, although it doesn't return anything. It just basically defines properties and methods. You'll also notice this is being used in here as well. It is basically saying that whenever one of these objects is created, the name will be equal to the name that's passed in, and the greeting method will basically set up everything for us. So they want us to add these two things in here. So they want us to get rid of the code that I had in here, put in this. So we're going to have two people, person one and person two. Person one is Bob, so it should be, hi, my name is Bob. And person two is Sarah. So again, it should be, hi, my name is Sarah. All right. Hi, my name is Bob. And if we change it from person 1, let's stop that. And let's put in person 2 dot greeting. And we get, hi, my name is Sarah. Now, the way that we just did that is the way that it's pretty much done in most programming languages. All right, so we could enter this stuff that's in here. Let's just see if we can enter all of this. Hi, I'm Bob. Hi, I'm Sarah. Okay, and if we just did in here just person1 dot name, just this, and put that in here, we get Bob. And if we did it with 2, we get Sarah. All right. It says you can now see that we have 2 objects on the page, each of which is stored under a different namespace. The first one is person 1, the second one is person 2. They do, however, have the same name property and greeting method available. All right, so let's look at the constructor. In each case, we use the new keyword to tell the browser we want to create an instance of a new person object. So it's let followed by the name of that object equals new followed by the name of the class. And since this class does require a name, all right, well, what happens? What do you think would happen here? I'm going to add a person 3. So I'm going to copy this down. And I'm not going to put in a name. I'm going to do it like that. Do you think that'll work? I'm going to guess that it will. It won't have a name, but I'm going to guess that it'll work. Oh, because I didn't change that to person 3, so I guess it wouldn't work. 3. But you did see that error saying it's already been declared, so we refresh. Now I'm going to put in here person3 dot name, and notice it's nothing. Could we have even done that and not put anything in there at all? So can I make a person 4 that has nothing in here whatsoever, like this? All right, now I know that in most programming languages, if you try this, you're going to get an error. I'm not sure what they'll do here. Just says that it's undefined because we haven't created it. Another time or another place where JavaScript is either really a good language or really not that good a language, because you can develop bad habits doing things like that. All right. In each case, the new keyword is used to tell the browser we want to create a new instance, followed by the function name with its required parameters in parentheses, and the results is stored in a variable. And that's what this is here. All right. So creating our finished constructor here, that's all that's left. And I'm at 18 minutes. Let's see if we can finish this. All right, it says remove the code you've inserted thus far and add this replacement constructor. This is exactly the same as the previous example was, except now we're breaking the name into a first and a last. We're adding an age and a gender, etc. All right, so let's put this in right here. So that'll be replaced with this. Now, just to show you quickly, I wouldn't normally do this, but I'm going to get errors now, I believe, in here. Now, when I say I'm going to get errors, maybe not right away, but eventually, because it's expecting a first name, a last name, etc., and I'm not providing it that. So if I come in here and I type in person 1, hit enter, well, it looks like it still did put stuff in there. I don't know. Try it again. Okay. Yep, it did. And since, again, age is undefined, gender is undefined, interest is undefined, so it did accept it, but it's not the way you really should write things, typically. All right, so let's go back into here. and let's add what they wanted us to add, which is person 1, and now this is Bob Smith. And when we come back here again and we refresh, now when we type in person 1, we hit enter, now you'll notice I'm not sure why it's not letting us. There we go. Now notice we've got name, first is Bob, last is Smith. We've got interests, again, of music and skiing. We've got the greeting, the bio, the gender, etc. All right. And that's pretty much it for what we've done so far. So there are further exercises. I, again, as always, would recommend that you take a look at that. Notice it says if you get stuck, they even give you the answer. All right. There is also an object constructor that you can use. All right. And if you put in something like this, let's get rid of everything that we've got in here. And now we've just created a brand new empty object. There's nothing in it. All right. We could come in and manually add this stuff ourselves, and it would work. Or we could pass an object literal in, and it would also work. All right. So it says try these examples. So let's quickly do this. I'm running way over on time. Sorry about that. Yeah, I'm at 22 minutes. So point is that this is going to still work. The person 1, and you can see the stuff is still being set in here. All right, Chris 38, etc. And we can also go in and do it this way instead, where we pass this in. To make this a little different, let's change the values just so you can see that indeed stuff is changing. Oops. So we'll put in here Mike. Mike is 22, and that's fine. We'll just do it like that. Come in here, refresh. Person 1 has already been declared. That's lovely. Oh. Refresh and put in person 1 again. And you get, again, Mike 22 and all the other goodies that I just put in here. All right. All right. Finally, using the create method, I didn't think this was that long still. Constructors can help give your code order. You can create constructors in one place, then create instances as and wherever they're needed. However, some people prefer to create object instances without creating constructors. So you can do it like this as well. So they want us to do this. Basically, what this should be doing, if I'm correct here, is it should copy everything from person 1 into person 2. All right. And then if we put in all this, person 2 is not defined. Well, that wasn't good, was it? Let's double check this. Person 2. I did save. Maybe I didn't refresh. Person 2.name, again, is Mike. Age, again, is 22. And greeting is hi, I'm Mike. All right. All right, that's it. As it says, this article provided a simplified view of object theory. All right. In the next lesson, we'll go into prototypes.